What's up, geometry? Thanks for tuning in for another episode of Math with Mullins. Today we're going to continue talking about Chapter 7. 7.2 is our lesson today, Properties of Parallelograms. We'll be able to use properties to find side lengths and angles of parallelograms and also to use parallelograms in the coordinate plane. A parallelogram, first and foremost, is a quadrilateral where both sides of opposite sides are parallel. We are going to talk about some theorems. This is a great time to get your theorems worksheet out. We're looking at 7.3 and 7.4. If a quadrilateral is a parallelogram, then its opposite sides will be congruent. So QP is congruent to RS, PS is congruent to QR, and then the parallel opposite angles theorem states the same thing but just with angles. So what we're going to do is we're going to write a proof here. I'm going to write a paragraph proof. If you want to do 2 columns, you can, but I feel like paragraph proofs sometimes just flow a little bit better. So given that PQRS is a parallelogram, we're going to try to prove that PQ is congruent to RS and QR is congruent to SP. From Q to S, so from Q to S is creating the diagonal of the parallelogram. Then I know that QR is parallel to PS and QP is parallel to RS using the definition of parallelograms. Angle PSQ is congruent to angle RQS and PQS is congruent to angle RSQ using the alternate interior angles theorem. I know QS is congruent to QS using the reflexive theorem. So triangle PQS is congruent to triangle RSQ using the angle side angle congruence theorem. So PQ is congruent to RS and QR is congruent to SP using the triangle congruence theorems. Okay. You could have also done another route too. If you used the parallel opposite sides theorem, you could have just stated that since this is a parallelogram and it's showing opposite sides are parallel, that means their opposite sides will also be congruent using the parallelogram opposite sides theorem. Okay. Next up, we're going to try to find the values of x and y. So I know that 2x should be equal to 54. So I'm just going to divide both sides by 2. So x is equal to 27. And then I know that 20 is equal to 3y minus 1. So looks like y will end up being, divide by 3. Y will end up being 7. Okay, so that's just using the opposite angles, opposite sides congruent. Next, we're going to talk about some consecutive angles, and I just wanted to show you these so you'd have them to write down on your chart. It just states that if you have a parallelogram with consecutive angles, then they'll also be supplementary. So x plus y in that first example is supplementary. And then the diagonals theorem just states when you have a diagonal, those diagonals will bisect one another, showing that QM is equal to MS and PM is equal to MR. Okay, so what we're going to do is write a 2-column proof on A, B, C, D, and G, D, E, F are parallelograms. How can we prove that angle B is congruent to angle F? A lot of different ways you can do this, but for the most part, we're going to try to stick to maybe a 4-step proof here. Okay, so statement 1, A, B, C, D is and G, D, E, F are parallelograms parallelograms, and that's my given. Okay, I know angle B is congruent to angle CDA, and angle F is congruent to angle EDG. That is using your parallelogram opposite angles theorem. Okay, so angle ADC equals angle EDG because those are vertical angles. So angle B is congruent to angle F using the transitive property of congruence. Okay? On the back, find the coordinates of the intersection of the diagonals for ABCD with these vertices. So first we're going to go ahead and plot these points. So I've got 1, 0 for A, 6, 0 for B, 5, 3 for C, and D is 0, 3. I'm going to do my best to make some straight lines here, and we'll find out where those diagonals bisect or intersect. So my diagonal hatches just go from opposite corner to opposite, and I think I can actually, let's see, draw a line. Except I do not want it that color because I can't see. All right, there we go. So there's 1, and then C to A, there's 2, and then you can kind of see that your intersection points looking like it's at 3, 1.5. So that's one way you can do it. The other way you can do that is find your midpoint of BD and find your midpoint of AC, and they will both be 3, 1.5. So they both have those in common. Okay. Then our last one, the next 3 vertices of DE, FG are -1, +4, 2, 3, and 4, -2. Find the coordinates of vertex F. So one thing you can do here is notice that you still want to have a parallel line, and you want to make sure that they have parallel slopes. So what I did here is I think about, okay, DE is a segment, and my slope to go from D to E is I'm running, or maybe from E to D, I go up 1 and to the left 1, 2, 3. So I might could do that same thing with F and create that same slope. Up 1 over 1, 2, 3. But I plotted F. Nope, I plotted F correctly. So 4, -2. Okay. So up 1 over 1, 2, 3. So I'm just copycatting that slope, right? So now looking at D to E, my slope is down 1 over 1, 2, 3. And then my slope for GF is down 1 over 1, 2, 3. So because they have the same slope, that means those are parallel lines. So all I have to do now is just connect D to G and E to F, and those should also have the same slope as well. I'm going to go ahead and mark my parallel here. So D to G is 1, 2, 3, 4, 5 over 2. And then E slope is 1, 2, 3, 4, 5 over 2. EF is also -5 over 2. So both of these have parallel slopes. Okay, proving that they have parallel lines. So point G is at 1, -1. Okay, that's all I have for us today. Thanks so much for tuning in. Hope this helped you, and make sure to tune in next time when we talk about 7.3. Have a great day.